All right, so we're down here in the chainsaw shop. I figured I'd give a little update video of what I'm working on. This is a 044 10mm saw. I originally bought it because I thought it was a 12mm saw, so I was going to put a 460 cylinder just like my 440 Farmer Tech hybrid, but it turned out to be a 10mm saw, so I never messed with it. But I figured that now I have two 50mm bore cylinders to do. I'd do them both at the same time. The other one's my 400C over there. I've had a lot of questions that people thinking that my 400C was ported, but I think it's just, you know, the combination of a sharp chain, a sharp square ground chain, you know, and just a couple simple bolt-ons. That's all runs pretty good. But I'd really like for it to be able to pull a 20-inch, because that's all I'm ever going to run on it, a little harder. So that's the reason that I tore that one apart, to do some modifications to that one, you know, support work, so that I can get a little more power out of it. That's probably my favorite saw to run, is that 400C. It's so light, it's so easy to use. So yeah, we'll get to that one in a minute. We'll kind of go over what's on this bench here first. I'm kind of doing multiple saw builds at a time, as you know, I have parts, you know, parts are coming in to do each one of them. So that's kind of, I'm just kind of bouncing around from saw to saw. The way I keep the parts distinguished, because a lot of these are similar, is I just have containers that I put all the parts in. Like you can see, this one here is the 461, is this one right here. And then sometimes I'll label them. It's pretty obvious when you do a lot of these, you know, what bolts go where, but I like to put them in a designated container. Like all the flywheel will go in one, all the muffler, you know, bolts will go in another. You know, it just makes it a little bit easier when you have them apart for a period of time while you're waiting on parts. So yeah, so if you're buying a saw on eBay or on the internet, Facebook, wherever it is, and you see a lot of like build up here, what this means is that someone was running a dull chain on it, in my opinion. It could be from, you know, wood that has a lot of pitch, like maybe pine too, but to me, how fine that the sawdust was and how it's caked on here tells me that this person was running this with a dull chain. They're running an 8-tooth. The reason that I don't run any 8-tooths anymore is, one, you're losing torque because this bearing is bigger. So it's just like a bicycle, you know, it's harder to pedal it. I mean, it's going to be the opposite here, but it's harder to pedal it when that gear in the back is really small, and it's easier to pedal it when it's bigger because you got more leverage on it. But it's the opposite with the chainsaw here. You know, it takes more power to spin a bigger rim. I guess a better comparison would be to, like, you got a truck, you put stock comes like 30-inch tires, then you put 35s on it. You're going to lose some mile per gallon and some acceleration by doing that. And with the chainsaw here, we're limited on power, and it's more noticeable, you know. So when you put a bigger sprocket on, you're losing torque, and then I feel that the chain kind of skips across the wood. It doesn't cut as efficiently as like the regular 7-tooth. So me personally, I like to run a 7-tooth with a more aggressive chain if the saw's got enough power to pull a more aggressive chain. I'm kind of dialing my chains into, one, what kind of wood I'm cutting, if it's oak, if it's pine, maple. And then I'm also dialing it in based off of how much power the saw has. So I've got kind of a little bit of like a sheet that I, you know, have for each saw. 500i's got a lot of torque, so I can run, you know, 50 thou rakers, and it pulls the chain fine. I can do the undercuts and, you know, kind of the plunge cuts, no problem with a 50 thou raker on a 7-tooth. I'm going to do a Meteor piston in here. Going to use the OEM cylinder. The cylinder looked fine, but the piston did not look fine, so I swapped the Meteor in. So with this build, it seems that the Meteor piston is pretty much a direct copy of the OEM STIHL piston. And the reason that I went with the Meteor over an OEM one is these are hard to get, and they're really expensive. And I have had, you know, really good luck with the Meteor, so I feel like the Meteor is fine. But this one had a little gouge here on the exhaust side. Had a little bit of wear on the bottom of the intake skirt. That's where they like to wear, right here. But this little gouge here, I didn't want to use this one based off that, and I wanted to at least do new rings if I'm going to do the port work on this one. So Meteor piston, caber rings. I'm going to run the OEM wrist pin, OEM bearing. You know, the bottom end feels fine. It doesn't have any play, so I feel that it's safe to do all this, and yeah, safe to do all this, spend all this time and get this one going. My plan with this one is I'm planning to sell this one when I get it done. I'll run it some, kind of show how much power it has. It'd be a good comparison to that 400C, because that one's 67 cc's, this one's I guess 70, so it'd be a good comparison of this one versus that one when they're both done. Next here we have my 461. So the reason that I bought this 461 is I watched some other people's videos on them porting them and looking at the case here, and I see that it'd be pretty easy to enlarge these lower transfers. You can kind of see the line here, hopefully on my GoPro, of, you know, how much larger you can make these lower transfers. And that was kind of the next experiment that I wanted to try, because like if you have let me show you a cylinder so you can see. So this is the 440 or 044 10 millimeter cylinder. The lower transfer entrance is at least the same size as the exit, and on these I would say it's really about half. You know, it's more close to half of that size. We're just kind of making it round so it's easy to understand. So I would think that there'd be a decent amount of pressure, you know, pressure 1, volume 1, pressure 2, volume 2. I would think there'd be a decent amount of loss going from half the size to double the size on the exit. So I was going to enlarge the lower transfers here. I will pull the flywheel off and the clutch off so that I don't grind through the case. I don't want to do that and have to put epoxy in it. So I'm going to try to be careful about doing this so that I don't make any mistakes, but I'm going to enlarge the lower transfers as much as I can on this build, and we'll see if that gives me better power. I'm going to order a second cylinder for this one to run the Wiseco piston. This one was ran quite a bit is what it looks like to me. So I kind of look at the intake side here. That's where the most wear is going to be, you know, when the piston is rocking in there. So I'm going to order an OEM piston cylinder kit, probably off of eBay, and then I will, you know, cut the base on both of these and then use this one as kind of my test mule cylinder to make sure I, you know, one, I don't grind through on the upper transfers, and then two, I, you know, don't grind through on the case. It just makes it a little bit, makes it feel a little bit safer doing it on a cylinder that I'm probably not going to use. So yeah, that's this 461. I've got, like I said, I got a Wiseco 4-inch piston for it. The pin to crown height is exactly the same. I think on their measurement sheet, how they're getting that measurement is to the top of the dome. I think this is a 064 one here, but it looks pretty much the same. It's the different pin to crown height. But they're taken from the pin to the top of the pop-up here, this little pop-up. And that pop-up's 2 millimeters taller in the center. So, and this is actually the 461 piston right here. This is what I'll use when I do the 461. I think I've kind of covered pretty much everything here. This is a full wrap saw, and it's got this nice muffler mod. I guess it looks like this was braced on, but I like the design of this muffler mod. I'm going to remove this baffle. I'll make a wooden block that I can clamp into the mill and just mill this out so that I don't have to deal with this baffle in here anymore. And then I'll probably enlarge these holes, move them back here. So like the thought is, you know, if this is on your saw, the more of you have your front wall with your front cover here. Your charge is coming out, it bounces off this front wall. Some of that's going to go back into the cylinder if you don't have something like a bark box on the front here where it's just allowing it to bleed off right out of the front. The bark boxes are nice, but I think that this will make more power. So I'm going to remove the screen and enlarge, you know, both these holes so that I can hopefully utilize that effect. Probably will At most, I may put another port up here on the top or put it back here. But I'm going to, oh, look at that. It's got a little pinhole right there. That's interesting. So probably clean up the brazing on this one so that it doesn't leak too, and then enlarge these holes in here to match what someone else has done here. I like this design. It kind of shoots it out to the sides. That's kind of cool. That was one of the reasons why I picked this one, because this guy had multiple of them for sale. I think this saw was like one of those saws that was on a crew or whatever. So hopefully, I mean, the bearings feel fine. I'm just going to put a new cylinder on it if I'm going to run that Wiseco piston. I'm not going to cut the skirt. So the Wiseco, the difference between this one and the Wiseco is, and I can just show you. Let's get it out here. Careful with it. Dimensions are pretty much the same. The skirt is a little bit wider, so I'll be able to hit that 65% of the bore, I believe, on the exhaust port width. Let's check real quick. We'll turn my calibers on. We'll go over to millimeters. I know the bore is 52. So 37.44. We'll do 35 divided by 52. So I can hit the 65% of the bore on the exhaust port width, which is what this one will go to, and have more of a rounded roof. Similar to the OEM to get better ring life. If you do a flatter roof on your exhaust port, it seems, and you do a wide width on the exhaust port, it wears the rings out faster. Hence why I had to put new rings in that 440. Pretty much what you'll notice is it'll run really good for a while. You know, you probably can cut, I don't know, 20 cords of wood, then you start to notice that it's not quite as fast as it was. But not saying that saw is slow or anything. Even after cutting a decent amount of wood on that FarmerTech 440 with the STIHL 046 D-chamber cylinder and 064 piston in it, it was like right with my 500i. So I'm curious to see with the new rings how it does now that I've got new rings in it. So I'll make a comparison video with that to my 500i, see if that one's faster. Now I didn't change the port work, didn't change anything. I just put new rings in it on that one there. But yeah, gonna go with a little bit more rounded roof for this build, I think, to get a little bit better ring life. We'll enlarge the lower transfers as much as possible to see if that helps with the power output. So this will be kind of an experiment here. I'm gonna probably wait a little bit, maybe till like halfway through the month, so that I can space out these charges on my card, because doing this is pretty expensive. Buying these saws and buying these new cylinders and stuff to do this it's pretty expensive to do all this. So this one probably won't be getting worked on until I have that new cylinder. I can cut both cylinder bases at the same time. And the piston and cylinder kit that I've bought recently is for my 661, so I'll have a couple 661 cylinders to play with. I've got one that has a blown out exhaust port hole, so I'm gonna cut the base on that one. This one I might send to Dyno Joe as like a core for him to do a 58 millimeter like he's done, since I got a 58 mil Wiseco piston for this one. If my version turns out good, I'll just buy a second 661, so I have two of them, and then one will get the Wiseco forged piston, and then mine will, you know, stay with the 56 millimeter 2100 piston that I, you know, did a bunch of work to get it to work with this saw. So pretty much like with my 661, what I'm gonna do is, once that cylinder gets here, I didn't check the shipping ETA on it, and then I have to do the machine work, so I won't be till like later this coming week. But I'm going to do something like what this 461 has to help feed the lower transfers, since the 661 case does not have the ability to open it up as much as this 461. So I'm just gonna do something like this with the 661 to try to get more charge into the lower transfers. You know, looking at how, you know, this system is working with the crankshaft, it kind of blocks off the charge going in, you know, since the crank lobes are kind of closing it off there. There's not a lot of area for the charge to come in, so that's why, like on this one, they've done this little relief here. And, you know, like this is for a 462. I just wanted to look at one of these to see if I could do a big bore 400C someday. Well, I had that 400C apart. So this is a Meteor 462 piston. I'm just going to use the rings off of this one for my 461 was the plan, since they're the same. I think they're the same height, and they're definitely the same bore size. So yeah, I was just looking at that. So you can see, like, this piston, this is the exhaust side for the 462. They want to get as much charge into those transfers as possible, so they've cut this skirt down pretty much as you can right from the factory. So there isn't that much room to take material out of the chamber and cut off the base, you know, with this design here specifically. So yeah, I think I've covered pretty much all I can on this 461. A little bit of what's going to be happening with the 661 once they get that cylinder. Let's talk about my 400C real quick. So I pretty much went to the max of what I could do as far as taking the material off the base. I just went right to the max of, you know, just enough for it to seal below the exhaust port, but there ain't a lot of room here to there isn't a lot of room below the exhaust port relative to what the piston skirt length is. This one's got aluminum bolts for the, oh, that's right there. It's got aluminum bolts that hold the cylinder down. That's pretty interesting here. I guess they were trying to save a little bit of weight. So I'll run the aluminum bolts with this one, I guess. I was just going to show you real quick what I'm talking about. So this is where the bottom of the piston skirt is when you have no base gasket. So I've cut 50 thousandths off the base here, 50 to 55 thousandths off the base, and that pretty much is about all you can do with this one. So we'll see what kind of compression gain I get. But yeah, the design of that piston is very similar to the 462 piston. These pistons are a lot different than, let's say, another Strato saw, which is the 372X torque. This one came off of my 372 Farmer Tech. So you can see that intake side is similar, but the exhaust side, look at the difference in the exhaust side there. It's quite a bit different. Taller pin crown height. This is a heavier piston as well. Maybe at some point I'll get a 572 and send that cylinder to Dyno Joe and get him to bore it out to 50 and put a sleeve in it for a 50 millimeter piston out of the X torque, since I got a decent X torque piston that came off of my 2172. But you can see these pistons are very similar in the design here. So this would be kind of a cool hybrid build to do too at some point. Probably would just get a second one if this one turns out good. A used one to see how this experiment would go. I was kind of curious of how long the skirt length is here, but if I'm going to get a sleeve put in, I can, you know, make the floor of that exhaust port however tall I want, you know, to get the amount of material out of the chamber that I want, and, you know, drop the cylinder down farther. But yeah, I just figured I'd kind of show you a little bit of what's going on with this, kind of a little bit of everything that's going on here. So I'm going to hopefully get this 044. That'll be the first one I do. Then I'll do this 400C, and then probably will be my 661 next. And then that 461 will be after that. That's what I'm thinking, just based off of, you know, trying to spread out the charges here as far as, you know, how much money does this cost to do this kind of stuff. I'm probably gonna, like I said, I'm gonna take the parts off of here, put them back on my Farmer Tech 440, and then put the original parts back on this one, these Farmer Tech parts, and then sell this 466. I'll sell it in ported form, probably sell it on eBay, but use the 460 cylinder that came with it. It's a D chamber style cylinder. I actually got it right here. It was easy to take material out of the chamber. I just checked it a little bit. So this cylinder, even though it's got this light appearance, it is easy to take material out of the chamber. And I've had pretty good luck with these Farmertech cylinders as far as you know, the plating not flaking when you're, you know, raising the transfers, raising the exhaust and stuff. So yeah, so this is the cylinder that's going to go back on that one. When I get to it, might jump into this one, since this will not cost me any money to you know, put this cylinder, port this cylinder, put it on there. I'll try a little bit different numbers with this one, see if I can get a little bit better performance. The numbers that worked in my 440 hybrid, which I made very similar on this one, did not work as well. So that just goes to show you how sensitive that these chainsaws are here. So I think I've covered all I can cover in this video. I probably will make some videos of me doing the port work and stuff on this one. Maybe start doing a little bit more of that, just to show a little bit more. But yeah, I think that's pretty much it for now. Thanks for watching.